Hello, dear students. I am your physics teacher, Himanshu sir, now online. Okay, so today we will start our topic in understanding a beautiful concept about electrostatic potential energy. Okay, so let's come to the whiteboard. So, electrostatic potential energy, what is that? So, like any ordinary potential energy, its notation is also represented by capital U. Understood? It is represented by capital U. So, what is potential energy? Class 11 study. So, class 11 study gives about the knowledge of potential energy. It is nothing but negative Warden of the conservative force. Oh my God, what was those terms? Conservative force. What is conservative force? Okay, for your simplicity, I am making the prior knowledge recapitulating here. That is, which energy? Conservative force. What are conservative force? Conservative forces are those forces whose work done does not depend on the path. That it is called state function. It depends only on the initial and final position of the journey or of the activity. Force applied in the initial position, that displacement occurs and it reaches to the final position. That is initial, that is final. Okay. So on which path it travels, it is immaterial. Any path, whatever may be the path it travels, the work done is same as it depends on initial and final position. Right? Such conservative force we have studied in 11, that is gravitational force, spring force, and now in 12th it is electrostatic force, right? So here it is all about electrostatic force. Understood? Okay. So let's move ahead. So potential energy is the negative Warden of the conservative force, or it is the positive Warden of the external agent. Which external agent? It is the external agent, means the work done by something, resources, means some battery may be involved, or we are involved. Okay, so that can be very well understood if we do work energy principle, work energy theorem. What is that? Work done by all the forces is equal to change in kinetic energy. That is why I am telling that bring the charges slowly so that the kinetic energy will never change, and thus make the kinetic energy change in kinetic energy zero. And work done by the conservative force plus work done by the non-conservative force and work done by the external agent, these three kinds of forces are there, and that makes the tally zero. And non-conservative force, you always know, you always witness that whenever we are talking about non-conservative force, we are making it constant, or it is not ideal condition we are making it. Okay, why? Because for your standard, for your 11 12 standard, you are not thrust upon all kind of criteria. Rather, we are solving it to the limited conditions, and on the future line, when you are studying BTech or higher education, then we will face all type of situations, right? So work done by conservative, work done by external is equal to zero, and it is quite evident that work by conservative is equal to negative work done by external agent, or negative work done of the conservative is equal to work done by the external agent, right? So thus the negative work done by the conservative is stored as potential energy, or work done by the external energy is stored as potential energy. And conservative force is because of the conservative force is because of the electrostatic force of attraction or repulsion. This electrostatic force of attraction or repulsion are the reason of work done by the conservative force. Understood? Okay, let's move ahead. So thus, whatever we have studied, let's recapitulate it. We have studied that whenever a charge is taken from one point to the another point by the negative burden or the conservative force, another constraint is there. We can't find the word potential energy, absolute potential energy. Rather, we are accustomed of finding difference of potential energy. That means U final minus U initial. That is negative burden by the conservative force, right? Then scientists, physicists are making certain arrangement so that absolute potential energy can be indirectly find out. Okay, and that is the reason why initial point of the potential energy is kept at infinite, and at infinite potential energy ceases, and that is the concept of infinite. Infinite is the point where the things have been overruled or things have been seized. Okay, and that is the reason why initial potential energy becomes zero at infinite. So U final will be remaining, and that is making the same work done by the conservative force. Work done by the conservative force work done by the conservative force in bringing the charge from infinite to that point of that configuration. That is the definition of potential energy. Because here configuration matters the most. Means the configuration in which it is kept at infinite should be recapitulated at the point of consideration. Let me complete the definition first, then we will learn it vividly, right? So let's make it here, note it down. So what is that? What is electrostatic potential energy? Electrostatic potential energy electrostatic potential energy of a system of charge. Here is system of charge comes into limelight. System of charge is the negative work done by the conservative force. That is electrostatic force of electrostatic force. Negative work on the electrostatic force from infinite to that point of the same configuration. Let me expand it on the next page. Okay, so take the screenshot, and so sir, we should move to the next page. Okay, next page. What we have studied, that configuration has to be intact. Means if this is a some smallest system of charges, two system of charges. Okay, two charges making a simplest system. One charge can be say system. That's why work done in bringing a single charge is zero. Why? Because here there is no constant, no external field, right? No external field, and there is no internal opposition or supposition. Means there is no internal attraction or repulsion of the charges. So when a charge is coming from infinite to the point, there is no opposition. So what done is evidently zero. But when second charge will come, that will be under the influence of the first charge. That means Either the first charge will make the facilitation or will oppose the second charge. If it will suppose, means it will affiliated, means if it is facilitate the motion, then that will make the charge movement easier. Okay, then work done will be something else. Okay, so that is the conservative force. And when external field is nothing there, but still second charge will feel either attraction or repulsion, and that makes the W2 to be something else, and that is the net potential energy of the system of charges. Understood? Once again, when there is a single charge, there will be no force in bringing it from infinite to the point of consideration. Why? Because we are supposing that there is no external field, and when a single charge is brought to that point, then there will be evidently no other charges around it. And that is why the single charge system will do zero work done. Remember the point, zero work done by the single charge. But the simplest system is configured of two charge system. Two charges separated with a certain distance. And that distance and angle should be intact in the process of shifting, right? Let's see the point A, it is Q1, it is B, it is Q2. So when Q1 is brought, then maybe here the point, then no work done and work down 0. When Q2 is brought and maintaining the same distance A and B, Q1 and Q2, then this is R12. Okay, so at this point, when before the charge came, the point is having certain potential because of this charge Q1. Understood? Let that potential is V1. Because of Q1, the potential is V1. Okay. In the prior classes, we have studied that potential is nothing but work done in bringing a test charge. So work done is evidently Q naught into V. That means any charge into potential gives rise to the work done of that system. Okay, in other sense, by using calculus, we can also calculate this type of things. But to make it easier, to make the derivation easier, such type of acceptance, such type of derivation, such type of prior knowledge has been used, right? So W becomes V1 into which charge is coming? Q2. So Q2 into V1. So let it Q2 V1 is what? V1 is the potential at certain point at position vector R12 because of Q1. So that becomes 1 upon 4 pi epsilon naught Q1 upon R12. And that's making the system 1 by 4 pi epsilon naught Q1 Q2 upon R12. Understood? So this is the expression. So let's move to the next page. So from those two instances, we have seen that the net work done is W1 plus W2, and the number one work done because of the single charge is 0, and the second charge is 1 by 4 pi epsilon naught Q1 Q2 upon R12. And this work done is nothing but, what is that? Potential energy, stored as potential energy. Okay. So work done in store, this is the externalization. So work done stored as potential energy, U is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R12. And this is because of the two charge system. So for two charge system, this is the potential energy. Understood? Very good. So now next move to the three charge system. I think after learning three charge system, you will get accustomed with the scenario. So let us Q, A point, B point, C point, Q1, Q2, Q3. Let the distance between Q1 and Q3 is R13, R12, R23. Okay. So there is a 3-charge system. In the same manner, we have to shift one by one and making the configuration intact. Understood? So let's bring Q1 first. So when you brought Q1, then there will be no work done. So right here, work done in bringing Q1 is equal to W1 is equal to 0. Very good. So now when Q2 is coming into the limelight, so Q2 is coming into the limelight at B point, A point, then Q2 is under the surveillance of Q1. That means it will experience a force of attraction or repulsion, and that is guided by the potential. So because of Q1 potential, V1 is felt at B, and because of Q2, the work done W2 will become Q2 into V1. So work done in bringing Q2 is equal to W2 is equal to Q2 into V1, and that becomes 1 by 4 pi epsilon naught Q1 Q2 upon R12. Very good. Understood? So about 2 charges we have considered, and we have written the desired work done. Now here it is Q3 and here is the point C. And when the Q3 is coming here, it is experiencing a force of attraction repulsion because of Q1 as well as because of Q2. And because of these two, there is a cumulative force. There is a two forces combining together. And as potential energy scalar quantity, they will be just algebraically added up. Okay, let's move to the next page. No, I am making the space here at the top. Okay, let's change the color because I think it is not making a greater impact on you. Red color is the most dominating color. Okay, so for Q3, so one work done in bringing Q3 is equal to W3 is equal to Q3 is under the impact of Q1 and Q2. That means V1 and V2, right? This will be the expression Q3. So it is W3. So Q3 V1 plus Q3 V2. And that becomes 1 upon 4 pi epsilon naught taking common Q1 Q3 by R13 plus Q2 Q3 upon R23. Understood? Understood? Very good. So it is W3. Now combining the all three will be the net potential energy of the system, right? So let's move to the next page. So potential energy is equal to total work done. Total work done in shifting the charge in shifting the system of charges. Oh my God, the system of charges. Very easy. So that equal to total work done instead of W1 plus W2 plus W3. As W1 is 0, so write 0 divided W2 is 1 by 4 pi epsilon naught Q1 Q2 upon R12 plus 1 by 4 pi epsilon naught Q2 Q3. So W3 Q3 Q1 Q2 Q3. Okay, R23 plus 1 by 4 pi epsilon naught Q1 Q3 upon R13. Okay. So total is 1 by 4 pi epsilon taking common. Q1, Q2 upon R12 plus Q2, Q3 upon R23 plus Q1, Q3 upon R13. Understood? So this is the final expression of the potential energy of the system. Three charge system, right? So three charge system का ऐसा निकलेगा potential energy. So this is all about electrostatic potential energy. बहुत ही कम समय में, within a span of few minutes, I am trying to make an impact on you. You should understand the concept in a very well manner. And in the next class, I will take certain questions which are frequently asked in the academic as well as entrance. Okay. So understanding is very important, and understanding can be brought by sincere problem solving. Okay. So with this note, give me rest. I am your physics teacher, Himanshu sir. Say bye-bye. Take care.